Welcome back to the deep dive. You sent us a truly fascinating stack of sources on the emergence of race-Q. And honestly, this feels like the moment high-fidelity telemetry, the kind you see in F1, finally arrived in horse racing. Okay, let's unpack this. We are diving into a system powered by just incredibly detailed GPS tracking.
Unbelievable, really.
We're talking 18 data points per
Yeah.
second for every single horse. And that all feeds into these sophisticated machine learning models from Ellipse and Racecourse Media Group. The promise here is massive, isn't it?
It is. The promise is introducing objective truth into a sport that has, for so long, relied on subjective observation.
On opinion.
Exactly. That's the core mission. For anyone who follows UK racing, you know the challenge is just the sheer variability. The tracks all have unique topography, hills, bends, dips, and the going changes daily.
And just for international listeners, when we say going, we're talking about the condition of the track surface. Whether it's heavy, soft, or good to firm.
And it fundamentally alters how fast horses can run. So traditional form study, it really struggles to standardize performance across all those chaotic variables.
So RaceQ steps in.
Yes. What the data does is transform that complexity into standardized, objective metrics. We've pulled out 10 specific professional ways. These metrics let you separate a horse's raw ability, its engine, from the confusing circumstances of the race.
The trip.
The trip. This is basically the top 10 ways to use this data to instantly upgrade your understanding of race form.
10 ways to get a critical edge. I like it. Let's start with the most fundamental challenge, benchmarking the result. You look at a race time and you wonder, was that actually fast? Or was it slow for those conditions?
And that's where our first two ways come in. They focus on establishing that objective, time-based baseline.
Okay, so way one. Use par time to establish the objective baseline. Now, we have the official race time. Why do we need this special calculated par time?
Because, like you said, time is almost meaningless without context. A blistering time on good ground would be a crawl on heavy ground.
Right.
Par time is necessary because it's the expected winning time for that specific race, and it's calculated before the runners even leave the stalls.
How does the model even begin to calculate that expectation?
Well, it's pretty powerful stuff. The model is trained on 10 years of historical data, and it adjusts for 4 critical factors all at once: the course, the distance, the class of the race, and the official going description.
So it's not just a simple average.
Not at all. It's a conditional average customized for that exact moment. So pre-race, you have this solid target time, this piece of objective truth.
And analysts use that to see if the actual time was quicker or slower.
Instantly. And this is so important for giving context to debutantes, horses with no past form. Or, more subtly, it can help you spot discrepancies. If everyone runs 2 seconds slower than par, the official going description was probably a bit optimistic.
That makes perfect sense. Okay, that brings us to way 2. Contextualize performance quality with the time index. So if par time is black and white, faster or slower, where does the color come from? How do we know if faster was significantly faster?
That's the time index.
Yeah.
It's a normalized, instantly digestible score out of 10. What's fascinating here is how it solves the nonlinear relationship between distance and time variance.
Okay, explain that, the nonlinear problem.
Think about it this way. A horse running 1 second quicker than par over a 5-furlong sprint. A very short race that's 0.2 seconds per furlong faster.
Right.
That is incredibly hard to do.
Right.
But that same 1 second advantage over a longer race, say 1 mile, 2 furlongs, only works out to 0.1 seconds per furlong. The significance is completely different.
Ah, okay, I see. The shorter the race, the more dramatic that 1 second difference becomes.
Exactly. So the time index is essentially an equalizer. It adjusts for that distance scale.
So a score of 9 is always a top-tier performance.
Always. It instantly tells you the race was run significantly faster than par, letting you assess the quality of that win in a single comparable number, whether it was a sprint or a middle-distance race. It's the true measure of speed.
Now we move from the macro result to the micro journey. We're getting into sectional data. This is the bread and butter of finding the unlucky losers, isn't it?
This is about determining how the race unfolded, where effort was gained or lost during the running itself.
So way 3, identify optimal running patterns with par sectionals. How does this metric map out the quote-unquote perfect race?
Par sectionals represent the model for the optimal way a horse should travel through each individual furlong to hit that benchmark par time. And because of the unique topography of UK tracks, the camber, the undulations, the ideal pace profile is constantly changing.
So the ideal sectional at a flat, speedy track like York is completely different from the ideal at, say, a tight, undulating course like Chester.
Completely different. Absolutely. So by comparing a horse's actual sectionals against this optimum, RaceQ reveals immediately if it ran evenly or, crucially, inefficiently. The pace is then just categorized simply. Very slow, slow, par, fast, or very fast.
Here's where it gets really interesting. Way 4. Isolate pace bias with finishing speed percentage, or FSP. So how do we use this to spot a horse that ran a suicidal pace early on and just burned itself out?
FSP is really the definition of pace distribution. It measures the horse's speed over the final sections of the race compared to its average speed over the entire race.
Okay.
So if a horse finishes just as fast as it started, the FSP is close to 100%. If it slows down dramatically at the end, the FSP drops way down.
And the par FSP itself is key here because it varies so much by track, right?
It is entirely relative to the course design. Take the famous course at Epsom. The 1-mile, 4-furlong Derby course starts with a steep incline, so it has a natural par FSP of about 112%.
So horses are expected to go a bit steady early on.
They are. But conversely, the flatter 6-furlong sprint course there has a par FSP closer to 103%.
That's a huge difference. So if you're looking at that Derby course, par FSP should be 112%. But a front runner had an actual FSP of, say, 92%.
That's your flashing signal.
Right. They've gone way too fast early and just crashed.
That's the actionable signal for spotting a burnout bet. The horse finished poorly, maybe beaten 10 lengths, but the data proves it just expended way too much energy too soon. It had the engine, but the ride or the tactics were all wrong.
So you mark that horse up for next time.
You do. You mark it for when it's ridden more patiently or maybe dropped in distance.
And that leads into the final part of this section, way 5, spotting the hidden upgrade in sectional closers. This is the post-race analysis goldmine, isn't it? Finding the unlucky loser that everyone else just missed.
It is, and the professional rule here is simple. Ignore the finishing position in the margin for a moment. Instead, you look for the horse that lost, maybe beaten by 5 lengths, but recorded the fastest closing sectional of the entire day.
Okay, but if a horse finished 5 lengths back but closed faster than anyone, isn't there a risk we're just overrating it? Maybe they were just running past exhausted horses.
That's a critical question, and that's where the GPS data is so key. Because RaceQ tracks every horse simultaneously and compares that closing fraction to the par for that section. This horse achieved genuine high velocity at the end.
I see.
It tells you the horse had immense latent speed and power, but something traffic, a poor tactical spot running wide, hindered it earlier in the race.
So this is the very definition of an inefficient loser. Their strong engine couldn't be fully deployed.
Exactly. This performance demands a massive upgrade in your form book. You mark them as a BAC next time contender because their raw ability was hidden by the circumstances. They just need a clean run.
We've focused entirely on flat racing so far, but RaceQ also offers specialized tools for national hunt or jumps racing. And there, the single biggest variable isn't always speed, it's jumping ability.
We need metrics that can isolate the skill of jumping from the speed of running. Otherwise, the form book is just unreliable. We're jumping the fence, so to speak, into national hunt analysis.
So way 6. Separate the engine from the chassis using the jump index. What exactly does this 0 to 10 score quantify?
The jump index quantifies the horse's jumping ability and efficiency, how technically clean, fast, and economical the jump is. And its unique benefit, the revolutionary part, is that it allows for non-competitive comparison across different conditions and tracks.
You mean I can compare a performance on soft ground at Cheltenham directly with one on good ground at Sandown, even if the horses never raced each other?
Yes. Traditionally, you could never properly compare those two performances. The jump index is standardized. The course material gave a great example before the 2024 Henry VIII Novices Chase. Analysts could compare Lodusud's excellent 8.4 jump index rating to down memory lane's 7.5.
And that predicted advantage in technical skill was reflected in the result.
It was. It confirmed that the objective data quantified who had the superior technique, separating raw speed from execution skill.
Which leads directly to way 7, quantify the jumping penalty with lengths gain jumping, or LGJ. This sounds complex. How does a professional use this data to make a strategic decision for the horse's next race?
So LGJ measures the horizontal distance lost or gained purely through the physics of the jumping action. It's independent of the horse's speed between the fences.
So it's about momentum killed midair.
Precisely. Now imagine a horse finishes third, beaten by 2 lengths, but the data shows it had a negative LGJ of minus 5.0.
Wait, so the horse lost 5 full lengths just on poor jumping technique, yet was only beaten by 2 lengths at the line.
Exactly. That means its raw running speed, its engine, was actually 3 lengths faster than the winners between the fences. The jumping, the chassis just failed it. The actionable play here is to wait for this horse to switch to hurdles, where the obstacles are smaller and the jumping penalty is minimized. Or race it on an easier jumping track like Musselburgh.
Yeah.
That allows its superior speed rating to finally be unlocked.
That's a brilliant strategy. Okay, switching back to the flat. Let's look at the crucial element of the start. Way 8. Measure tactical speed with the 0-20 mile per hour metric.
This metric is just fundamental for sprints. It measures the horse's raw acceleration, and it's displayed in race before the end of the first furlong. It quantifies precisely which runners break quickest out of the stalls.
And in a 5 furlong dash, that early positioning is often the entire race. So knowing which horses are naturally quick starters based on this objective metric lets you predict the early pace and tactics far better than just watching a replay.
Far better.
We're down to the final 2 ways, and they combine data points to create some truly robust predictive models. This feels like where the machine learning really shines.
This is where we move from generalized rules to hyper-specific contextual predictions.
Way 9. Adjust draw bias based on conditions. We've always heard generalities about draw bias. An inside draw is good, but race Q refines this dramatically.
It moves beyond those old assumptions by quantifying the draw advantage or disadvantage in actual lengths, and it adjusts for multiple factors at once: the going, field size, distance, and the course layout.
Give us that specific example from the source material about the bias reversal. It was stunning.
It shows the complexity perfectly. At the 1-mile, 4-furlong Derby course at Epsom, the model found a high draw is advantageous on good ground with 14 runners.
Right, the conventional wisdom.
But, and this is the key, this bias completely reverses to favor low draws if the ground changes to soft.
Right, hold on. So the high draw advantage, a rule we've relied on for years at the Derby, it entirely flips just because the ground went from good to soft.
It does. The preferred running line and the tactics change completely with the surface. This is the kind of nuance that moves analysis from sort of inherited gut feeling to true data-driven science.
And finally, way 10. Profile horse stride against track topography. This sounds like matching equine biomechanics to geology.
It is exactly that. Professionals use stride data, specifically stride length and cadence, which is the turnover speed, to match the horse's physical build to the specific course profile. They classify horses into 2 main profiles.
Let's start with the one built for speed.
First, you have the galloper. These are horses defined by a huge stride length, typically over 25 feet. They're powerful, long-striding athletes, ideal for flat, wide, galloping tracks like York or Doncaster.
And you avoid them on tight tracks.
You should. You avoid them on tight tracks like Chester, where the constant need to check and turn just forces them to break stride, losing all momentum and efficiency.
And the other type, the high-frequency specialist.
The rever. These horses are defined by a high cadence, greater than 2.4 hertz. They're agile, quick accelerating, with a high turnover. Perfect for those tight, agile tracks like Chester.
But they struggle on the long straights.
They do. They struggle on long, undulating straights, like the Newmarket Rowley Mile, where they just get outgrounded by the sheer coverage of the gallopers. Understanding these 2 profiles ensures you're backing the right type of athlete for the specific athletic challenge of the track.
It's incredible. Every single track is effectively demanding a completely different type of equine athlete, and we now have the data to measure that demand objectively. So what does this all mean? We've covered 10 objective, data-driven ways to analyze a horse's performance. The power of these core metrics, the time index and especially the jump index, is their ability to overcome that huge chaotic variability in UK racing. They strip away the noise.
They provide a structured framework. But it's crucial to remember that this data is an augment to, not a replacement for, nuanced human judgment. The models, even with a decade of data and 18 points per second, they can't account for everything.
Like a localized headwind.
Exactly. Or ground riding, just a little slower than the official description.
Yeah.
Human expertise is still absolutely necessary to contextualize the objective facts the data delivers.
You now have the 10 essential ways professionals are leveraging this high-fidelity data to redefine race form analysis and find that hidden value.
And, we've focused heavily on form study and finding betting value, but remember the broader context of the GPS data itself. This exact same platform is also being used to study equine welfare. We saw how precise and predictive the jump index is in a competitive context. So if that jump index proves robust enough to predict safety incidents before they happen, what does that mean for its future role? Will these objective metrics transition from being just a powerful betting tool into a necessary, mandated regulatory tool for racing safety?
Something for you to mull over until our next deep dive.